Have you ever felt that that dizzying sensation of drowning in information?
Oh, yeah.
Like you're just treading water in this sea of data, struggling to make sense of endless complexity,
hmm
or, finding your most important goals are just slowly, frustratingly drifting out of reach?
Definitely. And then sometimes out of nowhere.
Exactly. That moment of pure clarity, that flash where everything just, well, it clicks into place, right? You see the pattern.
It's that feeling of true understanding. It's rare, though. Exhilarating, but rare. Chaos turning into clarity.
Yeah.
But imagine if you could, engineer those moments.
Mm-hmm.
What if clarity wasn't just some happy accident, but something you could manufacture? Precisely, repeatedly, whenever you needed it.
That's a bold promise.
Mm.
Manufacturing an "oh" moment sounds almost paradoxical, doesn't it? Something so personal, so elusive.
It does.
But today we're embarking on a deep dive into a revolutionary technology that claims it can do just that. It's designed to fundamentally change how you interact with information
Helping you sharpen your vision as you zoom out.
and navigate your world from tomorrow, not just, reacting to yesterday's events.
Yeah, this deep dive pulls from some really fascinating source material. We're looking at a utility patent application and related documents describing something called a Human Intent Amplification Engine.
Right. And its core innovation, the Fractal Identity Map, or FIM.
Exactly, Fem.
So our mission today is to unpack all this intricate material. We want to cut through the technical jargon, really, and reveal the profound implications for how you gain knowledge, make decisions, achieve what matters most.
And hopefully without feeling completely overwhelmed in the process.
Right. So where do we even start with something that promises so much, maybe with its most mind-bending claim, this inverted resolution idea?
Yeah, let's start there.
When you think about any map, right, or even just looking at a picture, as you zoom out, things always get blurrier. Less detail, more overview. That's just how it works.
Always.
But FIM apparently turns that completely on its head.
That's correct. The patent literally claims it's the only map where more territory means more detail.
More territory, more detail.
Yeah. It's a fundamental defiance of how we perceive information at scale. Instead of losing fidelity, the bigger picture somehow gets sharper.
That really does sound impossible. What's the foundational idea? What makes that inverted reality possible?
It's built on this core idea. Position equals meaning. Okay, think about traditional systems. You've got your data, the territory, and then you have a separate organizational layer, like a map or a database schema, right?
Sure. Data and structure. Separate things.
Fact smashes that separation. It says the map, IS, the model. Meaning isn't just linked to a data point. It's inherently encoded in its precise position within the map structure.
So navigating to the data is the same thing as understanding it.
Exactly. The act of finding it tells you what it means in context.
Okay, and this is where it gets really fascinating. This inverted reality enables some pretty bold claims, like offering you 10,000 choices, zero confusion, which isn't about hiding options, is it? It's about organizing them so perfectly that the complexity itself becomes simple.
Precisely. It's not simplifying by removing information. It's clarifying through structure. Imagine you have this huge universe of options, but because they're laid out with inherent meaning in their position, there's no overwhelm.
The organization is the clarity. That's a profound insight. It's not less information, it's just perfect intuitive organization.
And it describes itself as complexity that simplifies itself. Like, think of a tangled ball of yarn.
Okay.
FEM doesn't cut threads away. It untangles them, organizes them into these neat, multidimensional spools, almost like a fractal pattern.
Self-similar patterns.
Yeah. The complexity is still there, but because it's organized so effectively by connecting meaning right to the structure, it feels simple, it feels intuitive, navigable. You find what you need quickly.
The demo they describe sounds, well, brain-breaking. You start with one dot, right? Your current state, maybe.
Right.
Then it expands to show, say, 10,000 possibilities branching from that. And you literally watch them self-organize into meaningful patterns right there on the screen.
Yeah, it's dynamic.
And here's the kicker. As you zoom out, those patterns actually get clearer, not blurrier. And you can supposedly make a complex choice in just, 30 seconds.
It completely challenges our assumptions about UX, about cognitive load.
Absolutely. Which brings us to the anti-patterns, as they call them.
Right, where the standard industry wisdom is less is more.
MFAM says more is clearer.
And where others say simplify to clarify.
FM says organize to transcend.
It's an inverted UX. It flies in the face of established things like Hick's law, more choices slow you down, or Miller's law about short-term memory limits.
But FM shows that more organized choices can actually lead to faster navigation and instant clarity, because the organization itself provides the map, the context.
Yeah, the structure does the heavy lifting.
It's really defying decades of orthodoxy, which I
Oh.
guess brings us to the patented breakthrough itself. Because this isn't just a different design philosophy, it involves breaking a pretty sacred rule in computer science, doesn't it?
Oh, absolutely. A really fundamental one, laid down by E.F. Codd back in 1970, the father of relational databases.
Right. What was Codd's principle again?
Basically, that logical data structures, like how you think about your data, its relationships, must be strictly separated from physical storage representation, like where the bits actually sit on a disk.
Okay, like the file name is separate from the actual sectors on the hard drive.
Exactly. And that separation allows for data independence. You can change the storage underneath without messing up how applications see the data. It's been gospel for, what, over 50 years now. Every database textbook, every system architect lives by this.
Until FIM,
Yeah,
which intentionally violates this principle.
deliberately, yeah. The invention basically says, look, that very separation was the roadblock. It stopped us from creating a system where the map could be the model.
That sounds almost heretical in computer science terms. How does it even work? How do you break that rule without everything just collapsing?
So it is pretty radical. The core, the beating heart, as they call it, is this thing called the unified weight rank mechanism.
Okay.
Imagine if every single piece of information, doesn't matter if it's a chunk of data on a drive or a concept in a hierarchy, had a unique address. But this address also tells you its meaning and how it relates to everything else.
Like a semantic address.
Pretty much. This mechanism uses the same consistent weight-based rule for both physical storage blocks and logical hierarchy nodes. These weights dynamically create these sortable prefixes, these semantic addresses.
So standard sorting can suddenly achieve meaningful semantic ordering.
Exactly. It creates this powerful dynamic pulse through the whole system, where structure and meaning are unified, one and the same.
Wow. Okay, so by daring to break this 50-year-old rule, what does it actually achieve? What kind of performance are we talking about?
The advantages are potentially huge. They talk about exponential query efficiency using something called a CTN skip factor.
Okay, break that down a bit. CTN.
Right. Think of C as the number of relevant categories you care about in one dimension, and T as the total number of categories in that dimension, is how many dimensions you have. Because meaning is tied to position, FIM can instantly skip huge chunks of the data structure that aren't relevant. Doesn't need to read everything. So if you're searching across, say, 3 dimensions, and only 10 out of 100 categories matter in each dimension,
So C10, T100.
then FIM only needs to look at 700 cubed, which is 0.1% of the total data space.
Only 0.1%.
Yeah, that's how you get these claimed speeds, like 361 times faster medical queries or 3,750 times faster supply chain optimizations. It just ignores almost everything else instantly because the structure tells it where not to look.
Those speed improvements are phenomenal. But hang on, let's talk about that black box problem. AI gets super complex, super fast. How do we trust its decisions? Especially if it's crunching data this fast. Does help with that?
Yes, that's actually a critical part of the design.
Oh.
Introduces this E parameter. E is basically the sum of the depths you have to go down in the hierarchy across all dimensions to find something.
Okay, and what does that mean for explainability?
It means any decision, any piece of data retrieved can be fully explained by tracing back at most E steps, E prefix relationships. They call it constant time interpretability.
Constant time. So it doesn't matter if you have 1 million records or 1 billion, the explanation takes roughly the same effort.
Exactly. The explanation time depends on the complexity of the query structure, the E value, not the total volume of data. The system structure is the explanation. You can follow the path, like breadcrumbs, showing exactly how it reached that insight or decision. Verifiable.
That's huge for trust, especially in critical areas. And it needs special hardware too, right? It's not just software.
Correct. This isn't just an algorithm, it's a fundamental rethink.
Yeah.
They mention specific hardware, like a semantic address bus, that directly implements this unified addressing. That's how they claim things like a 94.7% cache hit rate.
Which is incredibly high.
And a staggering 55,294 times improvement in power efficiency over GPU baseline. The hardware has to actually think in meanings, not just process bits in the traditional way.
Okay, let's shift from the pure tech. How does this FIM stuff translate to, real-world impact? And this idea of a temporal advantage? Because you mentioned it connects to a very human problem, goal drift.
Yeah, goal drift, we all experience it, right? You have these high-level intentions, things you want to achieve, but somehow they don't quite translate into daily actions.
Yeah, procrastination, getting sidetracked.
Often it's described as a failure of structure, not necessarily a lack of willpower. Your big goals aren't connected tightly enough to your immediate tasks.
Okay, I see the connection.
And this isn't just personal. The AI alignment problem, getting AI to stick to human intentions and values, that's basically goal drift at a planetary scale.
Ah, right. So FIM by being interpretable by design.
Exactly. Transparency is built in, not bolted on afterwards.
You're
It inherently addresses that black box enigma and the potential for value drift in AI. It allows for what they call verifiable competence. You can check its work. That's essential for critical applications, medicine, finance, infrastructure, where trust is non-negotiable.
And beyond trust, there's this temporal arbitrage or timeline sovereignty concept. What's that about?
It means the technology offers more than just clarity now. Because of its unique structure, how it organizes information based on meaning and relationships, it allows you to spot patterns before they become obvious outcomes.
Seeing the future, almost.
Well, maybe not crystal ball stuff, but it lets you connect dots before your competition does. You can effectively navigate from tomorrow, making decisions based on emerging patterns rather than just reacting to yesterday's news. It gives you a significant foresight advantage.
Okay, let's make this concrete. Like give specific examples, right? Like in medicine.
Yeah, the medical diagnosis example is powerful. It claimed 361x speedup, getting a potential diagnosis from 10 million patient records in just 23 milliseconds.
23 milliseconds.
With 97.3% accuracy, they claim, and crucially, 100% traceable explanation paths. So a doctor could ask a complex query like, respiratory conditions in pediatric patients with abnormal CBC results.
And get an instant transparent answer showing why the system suggests something.
Precisely. Think about that. For a clinician facing a complex, maybe rare case, that speed plus the traceability, it frees up their time from searching to actually thinking and making informed decisions, potentially life-saving.
And in finance,
A 95x reduction in computation time for risk assessment, crunching complex risks across 10,000 financial instruments in just over 3 seconds. Again, with that super high cash hit rate suggesting efficiency.
wow. And supply chains.
That's the really eye-popping number, 3,750x speedup, optimizing inventories with millions of SKUs in 12 milliseconds.
Okay, 3,750 times faster.
Yeah,
It sounds almost unbelievable, but if it's real, think about avoiding those just-in-time supply chain nightmares we've seen. Or identifying critical shortages way before they bite. That's a massive game changer for businesses and for us as consumers, too.
and it includes the ability to spot those low-probability, high-impact scenarios, like the example they give, a rare earth shortage affecting specific chip SKUs, finding that needle in the haystack before it shuts down production lines.
How does it find things like that, those rare events?
That links into another really interesting concept, aware blind spots.
Aware blind spots. What are those?
So VAR-IM doesn't just ignore or prune irrelevant information to be fast. It actually represents these pruned regions explicitly with metadata attached. It knows what it doesn't know or what it deemed low relevance for a specific query.
It turns unknown unknowns into something you can actually query.
Kind of, yeah. It makes them queryable features. So you can selectively explore these blind spots super quickly, like O1 access, if you're a domain expert who suspects something might be there.
Give me an example.
Okay, maybe a doctor is looking at pediatric respiratory cases. A mild skin rash might usually have a very low correlation, so it gets put in a blind spot for that query.
Right, normally ignored.
But FIM knows it's there.
Yeah.
And it might have metadata saying, hey, this normally low correlation rash actually shows up in 2.7% of these rare pneumonia cases. So the doctor can instantly be alerted to that specific low probability link and investigate further instead of the system just throwing that info away.
That prevents crucial details from being missed. That's clever. And they mention a product, Datacocha, already using this.
Yes, deployed in production apparently, helping users achieve goals, health, wealth, relationships, these multidimensional things, supposedly 30% faster. It does this by keeping these orthogonal life categories separate but connected.
Orthogonal meaning independent.
Yeah, structured so they don't interfere with each other, allowing cumulative progress across different areas of life without getting bogged down. It combats that goal drift we talked about.
You know, what's really insightful is how they frame the potential impact. They draw this powerful parallel to the Black-Scholes model in finance.
Ah, yes, that's a really telling analogy.
Why is that comparison so fitting?
Because, fundamentally, both Black-Scholes and FIM tackle a similar core problem. They try to create a computable language for a type of risk that was previously really opaque, hard to quantify.
Okay. For Black-Scholes, that risk was...
Options risk, specifically volatility. Before Black-Scholes, pricing an option was kind of a guessing game. The model provided a mathematical way to value that risk, making it understandable and tradable.
And that unlocked the modern derivatives market, right? Trillions of dollars.
Exactly. It turned options from a niche, speculative thing into a cornerstone of modern finance.
So what's the equivalent risk that FIM is supposedly creating a language for?
AI competence risk and trustworthiness. Right now, investing in or relying on complex AI can feel like a black box bet. Is it reliable? Will it perform as expected? Can I trust its outputs?
It's hard to quantify that trustworthiness.
Right. FIM, with its built-in explainability and verifiable competence, aims to make that risk quantifiable, transparent, auditable.
And just like Black-Scholes unlocked derivatives, FIM could unlock new markets for AI.
That's the vision. They imagine things like new financial instruments, maybe AI competence bonds, where the payout, the yield, is directly tied to an AI system maintaining a proven level of accuracy or performance.
Wow. Or insurance.
Exactly. Parametric insurance policies that automatically pay out if an AI operates outside its predefined, verified competence parameters. That could attract huge amounts of reinsurance capital, making large-scale AI deployment much less risky.
So it transforms AI from this kind of speculative, hard-to-value black box
into a transparent, auditable, and ultimately investable asset class, just like Black-Scholes did for options. That could massively accelerate investment and innovation in AI because the risk becomes manageable, understandable.
It really forces you to ask, if you can quantify and ensure AI competence like that, what new applications, what new markets suddenly become possible? Things that were just too risky before.
It's a profound question.
Okay, let's circle back to where we started, that exhilarating oh moment.
Yeah.
Because the claim isn't just that FEM enables clarity, but that its very architecture kind of mirrors how human insight actually happens.
Yeah, that's a key part of the philosophy behind it. There's this compelling parallel they draw between how FEM works its weight-ordered traversal, its pruning of irrelevant paths,
and how our brains work when we have an insight.
Exactly. Biological intelligence works by reducing cognitive entropy, that feeling of uncertainty, disorder. When you have an insight, your brain is essentially strengthening the relevant neural pathways and suppressing the irrelevant ones. Weber's process is designed to mimic that.
So the system isn't just finding data faster, it's almost fostering the conditions for understanding. Like it's structured in a way that promotes insight.
Precisely, and that leads to this idea of orthogonal multiplicative effects.
Orthogonal, independent again, multiplicative meaning.
Meaning if you have two truly independent factors or dimensions of information that each give you, say, a 10x improvement in understanding or efficiency.
You don't just get a 20x improvement.
No. If they're truly orthogonal, operating on different uncorrelated aspects, their effects multiply. You get a 100x improvement, just like different specialized modules in the brain work together multiplicatively. Weber's structure, with these independent dimensions, aims for the same thing.
They call it sailing faster than semantic wind.
Yeah, kind of a poetic way of saying you're generating compounded understanding, insights that are greater than the sum of their parts, by combining information from these distinct, meaningful dimensions.
That's a powerful concept. And how does this contrast with, say, standard ways of storing data?
Well, think about common data structures. A hash table is super fast for lookups, right? But it completely scrambles any semantic relationship between items. It just cares about the hash key.
Right. No inherent meaning in the storage.
Or a B tree, common in databases. It imposes a sort order, but it's often an arbitrary one, like alphabetical order, not necessarily based on deep meaning.
Okay.
Even modern vector databases, which are great for similarity searches, often work with these opaque distances in high-dimensional space. You know, things are close, but the meaning of that closeness isn't always explicit in the structure itself.
But FIM, because position IS meaning.
It naturally models how our brains seem to organize information. Related concepts are inherently closer or connected within the structure itself. The storage pattern reflects the semantic relationships.
So querying FEM isn't just retrieving a fact.
It's more like retracing the path of understanding, because the structure embodies the relationships and the meaning. That's why they call it a kind of cognitive prosthetic.
A cognitive prosthetic, it thinks with you, not just for you.
Yeah, it's designed to transform that scattered information overload into integrated understanding, because the integration is built into the very way the data is stored and organized. The architecture itself is a model of the discovery process.
So we've taken a really deep dive today into the Fractal Identity Map, FIM. We've seen how its patented inversion of traditional data architecture aims to bring unprecedented clarity to complexity.
How it tries to revolutionize AI explainability, making trust verifiable.
And how fundamentally it claims to mirror the very process of human insight. It's a system designed to help you operate not just by reacting, but from a place of deep, almost anticipatory understanding.
It really does challenge what we thought was possible in organizing information and maybe amplifying our own cognition. By weaving meaning directly into the fabric of data, it aims to make patterns visible much earlier, much more clearly.
So we'll leave you with this thought. If a technology really can manufacture clarity, precisely and repeatedly, if it can turn that feeling of information overload into actionable insight, what kind of future could you navigate?
What decisions might you make differently if you could genuinely operate from tomorrow, seeing those patterns before they fully emerge, really owning your timeline?
Something to think about.